Okay, YouTube, in this video we're going to continue our exploration of transformations of functions. In the last couple of videos we talked about how we can shift functions left and right, up and down using translation transformations. In this one we're going to focus on reflections, and we certainly have a couple of different types of reflections, but the one I'm going to actually explore with you here is going to be what we call an x-axis reflection. So we say another type of transformation is called a reflection transformation. And we say that these occur when either the x values or the y values of some relation are made to be their opposite. So let's consider this. We have f of x equals x squared, so our parent quadratic function that looks like a u. We also want to graph some g of x that's negative x squared. So in order to do this, as we typically do, make a table of values here. So we'll have our x values here. We'll do f of x equals x squared, and this will be our parent function of our quadratic here. And then we have g of x on the right here, and g of x is equal to negative x squared. And what I really want to point out is this negative x squared really is kind of like saying negative f of x, because x squared is equal to f of x. So we're going to talk about how that impacts our graph here, and we'll use a nice little battery of values here, negative 2 to 2 going by ones. So plugging these in, we would say, starting at, say, 0, we say 0 squared is 0, 1 squared is 1, 2 squared is 4. And going backwards here, we say negative 1 squared is also a positive 1, whereas negative 2 squared is also a positive 4. So our parent function of our quadratic here, which starts at 0, 0, and goes through 1, 1, and just happens to go through 2, 4, and be even and symmetrical about the y-axis and look like a u, but does certainly go through 0, 0, and 1, 1, and then looks like this. What I would like to explore is what would happen if we were to say, now let's do negative x squared. And so I just actually want to show you what happens when we plug in a negative 2 here. If we did negative x squared, really we'd be substituting in here for this x part, which is not squaring the negative out front. So if I substitute in a negative 2 here, I actually get negative positive 4, which comes out to be a negative 4. So this is going to be a negative 4. If I plug in, say, one more here, we'll do g of negative 1. We'd say that'd be the same thing as negative 1 squared, which negative 1 squared is positive 1, but we get a negative positive 1, which comes out to be a negative 1. What you're seeing is this. Because g of x is really f of x, where we're taking all of its y values and making them negative the y values of the original relationship, what you're going to see is that all of these values here essentially become their opposites. So the y values are becoming their opposites here, which means this would be a negative 1, this will be a negative 4 instead. And if we go graph these points, negative 2, negative 4, negative 1, negative 1, 0, 0, 1, negative 1, and 2, negative 4. What you see is that we get a what we call reflection transformation. And this reflection transformation occurred because if I were to label some points on the initial relation here, we say 1, 1, 2, 4. What I want you to see is if I label these down here, when I plugged in 1, I got the exact opposite y value. When I plugged in 2 in this one here, I got the exact opposite of what I did up here. So essentially, when we say negative f of x, we're really saying negative y. And what happens when you take a relation and take all of its y values and make them their opposites? Well, they have the same x values, but they happen to be located on the other side of the x-axis. So when I ask what are the same, about f and g here, we have the same shape. But we say what are different about them? We say g is an x-axis reflection of f. Okay, so I ask, what general statement can be made about a graph of a function g of x in relation to f of x if it's true that g of x really is just negative f of x? And what we're seeing here is if g of x is negative f of x, really what we're getting is an x-axis reflection. With that negative out front, what it does is it causes it to open downward, okay? So when we look at reflections here, let's generalize this. We say the graph of y equals negative the parent function, or negative f of x, is the graph of y equals f of x, but reflected over the x-axis. You can look at it this way. If we make our y values negative, which is really what we're doing here, then you get a reflection over the x-axis. So using this knowledge, what I want to do is this. I want to use the parent function f of x equals the absolute value of x, which starts at 0, 0, goes through 1, 1, and because we know our basic absolute value graph, we know that it looks like a b. So here's our absolute value function, f of x equals x. What I would like to do is really quickly say, well then how would g of x equal to negative absolute value of x affect this? And because we have that negative out in front of this x quantity here, what we're going to get is a reflection over the x-axis. So instead of opening upward, essentially what it's going to do is it's going to open downward. And this would be our reflection over the x-axis if we make our y values negative, if we have a negative out front, it reflects over the x-axis. Now, on the same note, we say that we could also commit a y-axis reflection. So the graph of y equals f of negative x. Now you notice the difference here is this. Over here we had negative f of x. So the negative was out in front of this f of x, or in front of the y. In other words, we were making the y values negative if that negative is out in front. So that's going to flip you over the x-axis. Here we are making the x values their opposites. And if you were to take a graph and keep all of the y values the same but make the x values their opposites, they would hop over the y-axis. So we're going to say in general, if we make the x value negative, y equals f of negative x, then it's really the same thing as the parent function but reflected about the y-axis. So what we're going to do to explore this is we're going to take a look at the graphs of f of x equals the cube root of x and h of x equals the cube root of negative x. You notice where I've made the x value negative. So start with your parent function of the cube root graph, which goes through 0, 0, goes through 1, 1. And just to make this a little bit easier on ourselves here, I'll plug in a couple of extra points here. What if we plug in 8? And the only reason I say 8 is because I happen to know the cube root of 8 is 2. So if I go 1, 2, 3, 4, 5, 6, 7, 8 would be about right here. It'd be about this height. And if I were to say, how about f of negative 1? We would get the cube root of negative 1, which comes out to be negative 1. And if I do f of negative 8, we would get the cube root of negative 8, which is negative 2. And again, I only chose these x values because they're convenient. But we say negative 1 went to a height of negative 1. And negative 8, which would be out here, goes to a height of negative 2. So here's our basic cube root function. Looks like this right here. We're going to label this f of x. This is our parent function. We say, well, then how would the graph of f of or h of x equals the cube root of negative x be affected? And what's really going to happen is all of these points, starting with, say, this 2, let's put this in green here, 2, 8. Really what we're doing is we're making the x value its opposite. So we get a reflection over the x-axis, and now it's going to be at this point here. Whoops, this is 8, 2. 8, 2. I mislabeled it. This will be at 8, 2. Sorry, folks. It'll be at negative 8, positive 2. And we'll say this point here, which was at 1, 1, was going to flip over the y-axis and be at negative 1, 1. And 0, 0 reflected over on the y-axis reflects onto itself. If we reflect this point over here, make its x value its opposite, and make this one's x value its opposite, it'll be at 8, negative 2. So we get this graph that looks like this. And you can see that it's really just essentially the same as the parent function, but reflected over the y-axis. So in general, if you have a negative out in front here, you're making your y values negative, which reflects it over the x-axis. And if you have an x value that you put a negative in front of the x value, inside with the x, you're reflecting it over the y-axis.